For our project, we did displacement versus distance, which is a common concept found in many calculus problems. Displacement is the net change over an interval. It's basically how far from the starting point something is at the end of the interval. To find displacement, you have to integrate the velocity function. With integration, you're finding the area beneath the curve from 2 points, A and B. A and B are the bounds. With displacement, the negative areas below the x-axis are subtracted from the total displacement. Distance is the total distance traveled regardless of direction. To find distance, you have to integrate speed, which means that you integrate the absolute value of velocity. While the bounds remain the same as seen in displacement, for absolute value, you have to find the roots of the velocity equation and integrate the pieces separately. When to use displacement and distance? For both, you have to look for keywords. In many calculus problems, it'll be specifically asked whether you should find displacement or distance using the words displacement and distance. Also, with displacements, you're finding the length of a curve, while with distance, you're finding how far a particle has traveled. In this little cartoon represented with a mouse and a piece of cheese, the displacement is seen as the direct path from start to finish, while the distance is highlighted in green by the complete path from start to finish. These graphical representations put displacement and distance into a greater perspective. As seen in this graph, the negative area is shaded in with a different color to indicate that it will be subtracted from the total displacement, creating the direct path from start to finish. With distance, the entire area is shaded one single color to highlight the absolute value aspect of distance, meaning that distance will always be positive, as the negative areas will never be subtracted from the total distance. You are finding the entire path from start to finish. So let's do an example. Let's find the total distance traveled by a turtle and the turtle's displacement for a turtle whose velocity is v of t equals 49 minus 9.8 t on the time interval 0 is less than or equal to t, which is less than or equal to 10. In this situation, our bounds are going to be 0 and 10, with a equal to 0 and b equal to 10, while our velocity function is going to be v of t equals 49 minus 9.8 t. Let's find the distance first. Total distance is equal to the integral of the absolute value of the velocity function. This means that the negative values become positive. When plugged into the equation, you get the integral from 0 to 10 of the absolute value of 49 minus 9.8 t dt. With absolute value, you have to determine if the body changes direction, the body being the turtle. To do so, you have to set the velocity equation equal to 0. In doing so, we found out that the turtle changes direction at t equals 5. With distance, you have to multiply the integral by -1 where the velocity is negative. In this situation, the velocity is negative from 5 to 10. This is where the minus sign in this equation comes in. We made the integral negative over here to make the distance positive. Now that we have our absolute function written out completely, we can integrate. After doing the integration, we found out that the total distance is equal to 245. Again, it's a positive number. So let's find displacement. Displacement is the integral of the velocity function. That means that the direct path indicates that the negative values stay. When plugged into the equation, we get the integral of 0 to 10 of 49 minus 9.8 t dt. When solving the integral, we find the displacement to be 0. This can be put into perspective with the graph shown on the right. We started at 0 and we ended at 0, indicating that the negative areas are subtracted from the total displacement, and the positive area and the negative area in this situation eliminated each other. Henceforth, our displacement was equal to 0. There you have it. The key factors and an example of how to use displacement and distance. Thanks for watching, and I hope you learned something new.